So here I want to have a look at what buffers are and how they work. So effectively, the definition of a buffer, it is a solution that resists a small change in pH. So if some acid or alkali is added, the buffer solution will work to make sure the pH doesn't change too much. And this is really important, especially in biological systems where the pH has to be preserved or enzymes won't work, won't do their job properly. So the most common ones we're likely to encounter are acidic buffers, and these can be made in two ways. We can mix a weak acid with a salt containing its conjugate base, or we can react a weak acid with a strong base like sodium hydroxide, which will produce the salt of the conjugate base. And provided we have put our weak acid there in excess, you'll see that what both of these are giving us as a solution of a weak acid and its conjugate base. And it's this solution that effectively is our buffer. So effectively what makes it a buffer is that we have the weak acid present with its conjugate base in a solution. So we set up, or we have this equilibrium, which we would normally have with a weak acid anyway, but in this time, by adding the extra salt, we've made this concentration large as well. So this is large. And of course, because the acid is hardly dissociated, only a small amount is dissociated, this is also relatively large. So effectively this sets up a system. If we add some acid to this, what we find is that the equilibrium here gets pushed to the left. So we've increased the concentration of hydrogen, it gets pushed to the left, forming more HA, and so removing the excess hydrogen that has been added. Or let's call it the extra, because excess has a specific meaning in chemistry. So in this way we've effectively minimised the effect of that H+, the acid that's been added. And then if we look at what happens when we add hydroxide to that hydroxide that we've added can react with the hydrogen ions here on the left hand side of the equation to form water molecules. And of course, because the hydrogen ion concentration has decreased, what will happen is our buffer equilibrium will be pushed to the right. So the equilibrium will be pushed to the right to form more H+ ions. And of course, because it's the concentration of hydrogen ions that determines the pH, by removing the hydroxide here and then reforming more hydrogen ions from the buffer equilibrium by pushing the forward reaction, we've effectively minimised the extra hydroxide that's been added and preserved the hydrogen ion concentration, thus preserving the pH. We can also make alkaline buffers by using a weak base and one of its salts. So these are more rare, but let's look at a common example. If we look at ammonia, and we'll take ammonium chloride as its salt. So here we would have the salt ion NH4, and that would be in equilibrium with ammonia, the base, and of course as it's a base it would accept a proton using a Brunstad-Lowry definition. And again, like with the acids, if we use in the base, the concentration of ammonia here is going to be high, and because we've added the salt here of the base, the concentration of ammonium, is also going to be high. And the relative concentration of hydrogen is low. And if you notice, this is actually quite similar in effect to the HA1, where NH4 plus is the equivalent of HA, then we have H plus, and NH3 would be the equivalent of A minus in the acid one. So again, it's a conjugate acid-base pair, and it's a question of making sure that you've got them the right way round. And this works in a very similar way. So if acid gets added to this buffer by way of hydrogen ions, what we see is that the equilibrium gets pushed to the left to form more NH4 plus, thereby removing the hydrogen ions here that we've added as an extra thing. And again, because the concentrations of ammonia, NH3 and NH4 plus are relatively high, this forms like a stable solution, so those are relatively unchanged. And it's the exact same thing if extra hydroxide ions get added. These will combine with the water molecules to form water, and this will have the effect of pushing the equilibrium to the right. So NH4 plus giving us H plus and NH3, forming more hydrogen ions and preserving the pH. So that's a qualitative explanation of how buffers work. A weak acid and one of its salts, or an alkali buffer would be a weak base and one of its salts.